To locate objects and events in space, we need three ideas: position, displacement, and distance traveled. We'll be working exclusively in one spatial dimension here. The SI unit for all of these distances, lengths, spatial measurements of any kind is the meter, lowercase m for short. So you'll need to convert all of your lengths to meters before doing any calculations. We have here a map of a one-dimensional world, which is just a line and several different locations marked on it. Of course, we have a reference point, 0, our P, our reference point, and the positions of other places with respect to that reference point. We're measuring all these distances in meters, our SI unit. So here our reference point is this tree, and we will be tracking the activities of a friend of ours, the mighty Chewbacca, as he goes about his daily business. Our reference point is the tree here where Chewie lives, and the position of a nearby gas station is marked 835 meters to the right of our reference point, so it's a positive 835 meters. Chewie starts his day here at his house. I will mark the event of him leaving the house in his car as x1. This is event 1, x for position. Chewie leaves his house and goes to the nearby gas station. The second event of the day is Chewie located at that gas station. We'll mark it x2, the position of event number 2 at the gas station where he buys his lunch. He gets a warm tuna salad sandwich, day old, out of the cooler. Chewie's next spotted over here at a nearby petting zoo. That's event 3, x3 for the position of event 3. There at the petting zoo, Chewie is seen vomiting near a sheep. Next, Chewie turns around, heads back to the gas station for event 4, x4, where he complains to the owner about the poisonous food in the cooler. Continuing on, Chewie goes past his house to the barber shop for a haircut. That is event number 5, x5, indicating the position of event 5. And finally, Chewie turns around, comes back home to his tree. The final event is him returning home, event number 6, x6. Okay, so our next idea here is displacement, the change in position between two events, the change in position of an object. Our object here is Chewie. And we indicate a change, as always, with the Greek letter delta. So delta x means the change in x, the change in position between two events. So the change in Chewie's position between events 2 and 3 is just the difference between his positions at those two events. x3 minus x2, always final minus initial. So his position at event 3 when he gets to the petting zoo is 1534 meters to the right of our reference point. So 1534 meters in the positive x direction. His position at event 2 was that 835 meters in the positive x direction. So the difference between those two is a positive 699 meters. That was his change in position between events 2 and 3. Let's, for future reference, mark on our map that the distance between these two events is 699 meters. Okay, how about his displacement between events 3 and 5 from the petting zoo to the barber shop? Displacement is final position, x5, minus initial position, x3. His final position is negative 992 meters. He's 992 meters in the negative x direction from our reference point. His initial position, x3, was here at the petting zoo, 1534 meters in the positive x direction from our reference point. So the difference between those two is negative 2526 meters. The change in his position was negative. Overall, between those two events, he moved in the negative x direction. Okay, between events 2 and 4, let's say. Always final minus initial, so his position at event 4 minus his position at event 2. At event 4, he's located here at the gas station, 835 meters from our reference point. At event 2, he's also located at the gas station, 835 meters from our reference point. So the difference between his position at these two events is 0. Now, he did move between these two events. He went here to the petting zoo and back again, but he ended up at the same place where he started. So the total change in his position is 0. So we see here that a displacement can be a positive number, a negative number, or 0 if you end up back where you started. All right, next concept, distance traveled. This is a little bit different. This is the change in what your odometer in your car would say. It's the total distance that you have moved, and it's always a positive value. So for instance, the distance you traveled between events 2 and 3. Well, he moved from the gas station to the petting zoo, and we know that the distance between these two locations is 699 meters. So he traveled 699 meters. The odometer on his car, if it was reading in meters, would have gone up by 699 in traveling from here to here. So in this case, the distance traveled is the same as his displacement. It's not always the case. Let's look at his distance traveled between events 3 and 5. Event 3 is at the petting zoo. Event 5 here at the barber shop. So the total distance he went was he had to go 1534 meters back to the reference point, then another 992 meters to get to the barber shop. So his distance traveled is a positive 1534 plus 992 meters. The odometer on your car doesn't know whether you're going forward or backward. It always increases. It only goes up. So 1534 plus 992 gives us 2526 meters. That's his distance traveled. Compared to his displacement between those two events, which is negative 2526 meters. The displacement tells us that he moved in the negative x direction. It's got some information about what direction he moved. But distance traveled doesn't tell us anything about what direction he went, only how far he went. Okay, and one more, the distance traveled between events 2 and 4. Here at event 2, he's at the gas station, 835 meters, and event 4, back here at the gas station. Okay, he ended up where he started, but in between, he moved 699 meters this way, and then another 699 meters back this way. So his total distance traveled is 699 plus 699. The odometer on his car would have gone up by 1398 meters. Okay, try some of these on your own. Pause the video for a moment and work out Chewy's displacement and his distance traveled between each of these sets of events. Ready for the answers?